Question number 33. A plane meets a set of three mutually perpendicular planes in the side of a triangle whose angles are A, B, and C respectively. So that the first plane makes with other planes angles the square of whose cosines are cot B, cot C, cotCcotA, cotAcotB. So this is a complicated question. So if you can see, a plane is meeting three mutually perpendicular planes. There is no particular equation given for a perpendicular plane, so we can assume any perpendicular plane. So for the questions convenience, so solutions convenience, we will take the coordinate planes as our three perpendicular planes. So as you know, if this x, y, these are the coordinate planes. So we'll just clearly these are the coordinate plane. So this coordinate plane can be represented by the equation z is equal to 0, and this coordinate plane can be represented by the equation, and this coordinate plane can be represented the x is equal to 0. X is, these are the three perpendicular planes we are considering. Now a plane meets these set of three perpendicular planes in a side of a triangle. Angles are A, B, C respectively. We can draw any plane that meets these three planes. So in the sides of a triangle, so we know we construct like a triangle we are very familiar with, a plane like this which meets the perpendicular planes in these sides of a triangle, right? So if you call this a zero B at this point, we know this plane. This is the standard equation. So plane is called this equation. So if you're not familiar with this equation, please check question 27. This is a standard equation which can be easily derived starting from the normal form of a plane and applying these 3 points to it. So anyway, if you still confused, go I have discussed that derivation in question 27. Please check that. So okay, anyway, this is our plane. Now a plane meets a set of three mutually perpendicular planes in the side of a triangle whose angles are A, B, and C. So triangles angles are given, so I'll just mark it as A, and this is, let this be the angles of the triangle. This is the triangle, okay? And so that the first plane makes with other plane angles the square of whose cosines are this. So what is the angle? The angles, the angle that is mentioned in the question. Plane and the one that plane makes with coordinate planes. So this is our plane. So this is our plane. This plane is making certain angle with different coordinates. So we can either the angle is given by, if you take this coordinate plane, the normal to the plane is, say normal to the plane is like, so you get an angle like this, right? this angle, complement of this angle is the angle this line, this plane makes with, and I'll just make it complicated. So say normal to this plane will be the outward direction. If you take an origin, to make it clear, if you draw a normal from origin to the plane and extend it outward, this is the normal normal to this plane. This normal, the angle this normal makes with the normal to the coordinate planes. So if normal to the coordinate planes will be in direction, this normal, the angle this normal makes with the normals of these coordinate planes will be is the angle mentioned here. The the angle made by first plane with the other planes. So let's, for simplicity, call those angles alpha, beta, and gamma. So that angles be, let that angles be alpha, beta, gamma respectively. The question asks, cos square alpha should be, we have to show that cos square alpha is equal to cot B, cot C, and cos square beta is equal to cot C, cot C, cot A, and cos square gamma is equal to cot A, cot B. So we have to prove this, where alpha and beta gamma are what? The angle this plane, this particular plane makes with different coordinate planes in our example. So we will see what is the angle alpha, beta, gamma. We find all the equations. So we will start. So this is what the question asks for. Little complicated question, but we'll see. Now we need to find, we have two lines. We need to find angle A, B, and C. What angle A, B, and C are. So if you see, if you take, let's call this point A. Call this. Now we have AC, dr of AB is direction ratio of AB, A minus 0 minus 0 minus B. So A minus B 0. Direction ratio of AC, direction ratio of AC is minus 0, 0 minus 0, A 0 minus. So these are the direction ratio of the two lines. Now we can find, since we need, the equations are in the form of what, we'll write tan. So in terms of tan A, what is tan A? Tan A, the equation for tan A is, when we know these direction ratios, is nothing but root of, say we have two direction ratios, A1, B1, and C1, and A2, B2, C2. These are the general direction ratios. Say, in such cases, tan of the angle between these two direction ratio lines with this direction ratio is given by root of sigma B1 C2 minus B2 C1 whole square by sorry, A1 A2 plus B1 B2 plus C1 C2. So tan of A is given by this general formula. Now we will apply this, which becomes sigma So B1 is minus B into C2. C2 is minus C. So BC minus B2 C1. So B2 is 0. So C1 is 0. So 0 whole square plus similarly we take all the other options. So B1 C2 similarly next one is 0 into 0. So that will become yes, that is C1 A2. B1 C2 minus B2. Similarly C1 A2 minus C2 A1. C2 A1 is also so first term is 0 and C2 A1 is minus C into A, minus of minus AC. So that becomes plus AC, the whole square. A1 plus A1 B2 is A into yes, A2 B1. A2 B1 is A into minus B, that is plus AB. So 0 plus AB. So what basically we are this equation expands to, if you have, can write like this. So here B1 C2 minus B2 C1 we are taking this. Now second one is A1 C2 minus A2 C1, and third one is A1 B2 minus A2 B1. What we are doing. So that by A1 A2 becomes A square, B1 B2 becomes 0, C1 C2. On simplification we get thus BC root of BC square plus AC square AB the whole square. So BC square AC square plus AB square B square C A square. Okay. Now this is tan A. Now cot A. So we in our equation it was full of cots. So we will just from this we can write what is cot A. What is cot A? Cot A is nothing but square by of B square plus square C square B. Now since this is a symmetric equation, we can easily write what similarly. We can write similarly what B is what B square by root of B square. You want to check, you can check, but we can easily write this. We got our cot A, cot B, cot C. Now we will see what alpha, beta, and gamma are. So we got our cot. Say angle plane 1 makes with coordinate plane x is equal to 0 is alpha. Just randomly say that is the alpha. So how do you find that? We have the direction ratio of plane 1 is 1 by A, 1 by B, and 1 by C. Normal to the plane. The direction ratio of normal to the plane is 1. So this direction ratio, and direction ratio of x is equal to 0. This normal. This, what will be the direction ratio of this normal, which is same as the direction ratio of this x-axis, 1 0 0 0. We have direction ratio of normal to the x is equal to 0 plane is 1. Now we just we have a direction ratio of normal to both these planes, and angle between these planes is nothing but angle between the normals of the plane. So how do you take cos alpha? So if cos alpha will become this 1 by A dot plus by B dot 0 plus C dot 0 by root of 1 by A square plus 1 by B square plus 1 by C square plus root of effectively cos alpha there, that become alpha is equal to 1 by A by of C square. So we got our cos alpha. You take squares, square alpha by A square. You take LCM and square it, as we get here becomes A square B square C square. So this term will be square C term, it will be A square C. Here this A square by into LCM. So now if you can see, this two cancel, B square C square by this term. Now if you see, this is nothing but cot B into cot C. B square C square and multiply, you cot B into cot C do, you will get the same term. Equal to sorry 3 and 4. Now we got cos square alpha is cot B cot C, which is what we needed to prove. Square alpha is. Similarly, if you take the cos, find cos beta, cos gamma. So you will get the required equations as cos square beta is nothing but, you get this cot C cot A and cot A cot B. I'm not going to write the entire steps. You can try it out, and if you're having any difficulty, I'll just solve it then. get this. I'm not going to solve this, but you will get these formulas. You solve for cos beta and cos gamma. So cos beta, just a heads up, cos beta is nothing but the angle. So you can beta angle plane makes with say with a y equal to 0, and gamma plane 1 that is equal to, can here the direction ratios of plane 1 is same, and the direction ratio of y is equal to 0 is nothing but 0 1, and here direction. If you see, you will get the equations, you will solve the equations just like this. So yeah, that is the solution to question. There is nothing, it's the solution uh, does not involve any complicated steps, but to understand this question is quite difficult. So they have made it very vague by saying three mutually perpendicular planes, and this statement and all are very confusing. So this is what they mean. So, and this is the solution to question 33. If you have any doubt, do comment. I will try to explain solution to